All right, so what's going on, guys? And this is a video review for the Chapter 4 exam slides. So the whole point of this is to get you ready for your test, obviously. So if you're watching this is probably my even classes, I'm guessing. And you guys are going to have your test on Wednesday, right? There's no school on Monday because of President's Day, and that's just how it's going to go. All right, so the whole point is obviously to get you prepared for the test. So what I want you guys to do is I want you to pair these slides with the study guide assignment that you guys did. You do those two together, right? Those from your study guide slide, those are screenshots from your test. So all those figures you're going to see are the exact same ones you're going to see on Wednesday. So if you pair this video, or you can look at the slides if you really want to, if you don't want to listen to my voice, you can do that. And you study that study guide, and you do those two things together, you're going to be ready, right? There's 25 questions. You guys will have the whole class to complete the assignment, and then you're going to go from there. All right. So here's what you need to know from chapter 4-1, right? The beginning of this chapter. And the reality is that it's not much. Okay. So what you really need to know is the idea of composition of rigid motion, right? There's those questions on your study guide. It's about as far as it's going to go. If you really want to go through and look at the chapter notes, of course, that would never stop you from doing that. But mainly, it's like, do you know what composition of rigid motion is, right? Like, would you be able to identify a reflection, translation, rotation? Do you understand the idea that if I use a reflection, translation, or rotation, that the shape doesn't change, right? It moves left and right. I can rotate it, I can reflect it, but at the end of the day, that shape is still the same, right? It still holds it's the same sides, right? The sides stay the same and the angles stay the same. And that's what we're looking for. So as long as you understand those concepts, you should be good for chapter 4-1. All right, now we're getting into the heart of this exam. Isosceles and equilateral triangles. So, as you guys know, there's two different kinds of triangles, right? There's an equilateral triangle and there's an isosceles triangle. An equilateral an equilateral triangle is a triangle with all three sides are equal. How do I know that? Okay, you guys can see being pointed at here are those sides. So the idea is I have a triangle, all the sides are equal, and when all my sides are equal, all the angles on the inside are going to be 60 degrees. Now, there's two sides of this coin, right? Sometimes they're going to show you a shape, or a triangle, I should say more specifically, with three equal sides. You have to have the knowledge that, oh, I see a triangle with three equal sides. Okay, I know that the angles on the inside are 60 degrees. Or it could be the other way around. Sometimes they're going to show you a triangle, and you're going to see that there's 60-degree angles there. Okay, so your job is to figure out, or to know, right? Oh, I see 60-degree angles on this triangle. I have to know that all three of my sides are going to be equal. Okay, it can work both ways. Sometimes your test is not going to give you both of those pieces of information. You have to pull one out just by looking at the tick marks and the arc marks. All right. The other one triangle, of course, is the isosceles triangle. Okay, an isosceles triangle is where two of the sides and two of the angles are equal. So let's go into that a little bit deeper. So as you can see here, if I see that two sides are equal, I know that those two angles on the inside are equal to each other. Okay, you can see those little fingers pointing towards the angles at the bottom. So in this case, angle C would be equal to angle A would be equal to angle C. Okay, and the opposite is also true, right? If I see that two angles are equal, the ones being pointed at, I would know that both of those sides, side AB and BC, are also equal to each other. So like I said, just like with equilateral triangles, it's not going to give you both of those pieces of information a lot of the times. You have to know, oh, I see a triangle with the angles on the inside equal to each other. So that means I have to know, right, because it's an isosceles triangle, that the sides opposite of those equal angles are equal to each other. Or right? In this case, if I see two sides are equal, which is usually what you're going to see, then you would know that the two angles on the inside are equal to each other, right? In this case, angle A and angle C are equal to each other. All right, so let's go into a couple of examples. I'm pretty sure this is like a question you're going to see in your test. The only thing that's missing is that that's just going to be a different number, right? It's not going to be 50 degrees. So what's going to happen is, well, I'm taking a look at this triangle. First thing I'm going to say is, what kind of triangle is this? Well, see a triangle with two equal sides, right? We know those tick marks mean that those two sides are equal to each other. So if those two sides are equal to each other, this is an isosceles triangle, two equal sides, means those angles at the bottom are also equal to each other. All right, so how do we figure this out, right? The inside of any triangle, when I add all three of the angles together, you can see the angles on the inside there, they're going to add up to 180. So all I have to do is set up a little algebra equation, right? 50 plus my unknown angle x plus my unknown angle x. I call them x, right, because I don't know what they are, but I know they're the same. So I'm not going to call one x and one y. I know they're the same, so I'm going to both call them x, okay? 1x plus 1x obviously is 2x, okay? X is basically like 1x. All right, so that's 50 plus 2x is equal to 180. All I have to do now is subtract 50 on both sides. Okay, 180 minus 50 is 130. The last thing I have to do, of course, is divide by 2 on both sides, and that gives me that x is equal to 65. Okay, so both of those, right, both angle F and angle E are 65 degrees because they're equal to each other. Okay, this is another example of a question that I'm pretty sure is like verbatim on your test. The only difference is that you're going to have different numbers, right? Everyone's going to have a different like version of the question. Well, we have to take a look at this triangle. Since these two sides are equal, I know this is an isosceles triangle, okay? That means that these two inside angles are equal to each other, all right? You have to be able to identify that. Now, one thing that I've seen is I'll ask you, you'll be able to correctly identify. A lot of you guys will say, oh, okay, it's those two angles that are equal to each other. And when I ask you to put it into an equation, you'll say negative 4x plus 9 plus 8x minus 3. But that's not what we're looking for, right? That we're equal to each other. So we got to use the equal sign, right? Negative 4x plus 9 is equal to 8x minus 3. Now, one thing that I want you guys to try to focus on for this exam, and something that I've noticed a lot, is for some reason, you'll always want to put the variable x on the left side of the equal sign, no matter what the situation is. Like for me, I like to do whatever is easier. Okay, for me, working with positive numbers is easier. So instead of bringing 8x to the left side, I'm going to go ahead and add 4x, right? It's negative 4x, so I have to do the opposite. So I'm going to add 4x on both sides. That way I'm working with positive numbers. Those are a little easier to work with. So I add 4x to both sides. You can see that in step 1. Okay, so it's going to give me 9 is equal to 12x minus 3. And then I can go into step 3, right? All I have to do is add 3 on both sides to get 12x by itself. That's going to give me 12 is equal to 12x. Last thing I have to do here, divide by 12 on both sides, and I get x is equal to 1, right? Easy enough. All right, so let's talk about finding angle measures. And, that's what x, okay, one thing I wanted to go before I move on. All right, yes, x is equal to 1 in this case. So sometimes the question asks you what's the value of x. Other times it's going to ask you for the value of the angle. So be careful. Make sure you always check. What is the question asking you? Is it asking you for the value of x, or is it asking you to take that value of x and plug it back in to find the number actual value, right? So you just got to be careful. Is it asking you for x? Is it asking you for the angle? Okay, always make sure. All right, so let's find angle measures in isosceles and equilateral triangles. This is kind of like a super example, okay? I have two triangles right next to each other. All right, so it's saying if angle CBD is 130 degrees, and I'll show you what that is in just a second, all right, what is the measure of BAD? So this gets into like a really important thing. This one goes over a lot of important topics. This is one of the best examples I can show you guys of this. So when I say angle BAD, you have to know that I'm talking about the one being pointed at, right? Angle BAD. A lot of you guys are good at tracing your finger over the figure to figure out where BAD is, but when I ask you, okay, that's good that you can trace your finger across the letters. That's like legitimately a good thing to do. Okay, but you got to know at the end of the day, what I'm talking about is that angle it's being pointed at right there in this figure. Okay, so we're trying to figure out that angle. Now it also tells us that this angle over here is 130 degrees. So now that's all the information that we really need. So we have to go one at a time to start figuring out these angles. What you'll notice here, right, the triangle on the left, the one that's being pointed at, has 3 equal sides. Well, if there's 3 equal sides, I'm talking about an equilateral triangle, right? The inside of an equilateral triangle, they're all 60-degree angles. Now, what else do we know? Well, the question told us that that whole angle, CBD, which you can see in the bottom right there, is 130. Well, if the side on the left is 60 degrees, the side on the outside has to be 70, right? 60 plus 70 is 130. So that whole corner is 130 degrees. So what I've done is it just got broken into 2 parts. Now let's take a look at the triangle on the right. You can see it's a triangle with 2 equal sides. Since I have 2 equal sides, the 2 angles on the opposite of those equal sides are equal to each other. So then all I have to do now is set up an equation, right? 70 plus x is equal to 180. All I have to do is subtract 70 from both sides, okay? So, well, first of all, x plus x is 2x. So 70 plus 2x equal to 180. All right, I subtract 70 on both sides. So 2x is equal to 110. Then all I have to do after that is divide by 2, and I get x is equal to 55 degrees, okay? The algebra part you guys should be pretty comfortable with. You should know how to do this. If you don't, you got to come see me, okay? Because that's a skill that you guys have to have had, down by now, all right? So 55 degrees, that ultimately is what we were asking for, right? What is angle BAD? Angle BAD is 55 degrees. All right, now we're getting into the meat and potatoes. This is what the majority of the test is going to be on, right? Isosceles triangle is a big part, but when it comes to the rest of the test, most of your test is going to be on side, 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 angle, side, angle, side, angle, 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 side, and the HL theorem, okay? That's going to be probably 70% of your tests. So let's go over the first part. All right, it's not on this slide, but the first thing you need to know is about side, side, side. You guys seem to get that one down pretty well. I'm going to showcase one a little bit later, okay, to show you exactly what side, side, side is, but the idea is pretty simple, right? If I have two triangles and they have three sides that are exactly the same, obviously those two triangles are equal using side, 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 all right? Now, so side angle side, okay, this is the book definition, but really what you need to know is in the whole section, when you're working with two triangles and you're trying to prove they're congruent using whatever method, what I like to do, and you can see here, okay, I like to highlight those congruent sides. And normally I'll highlight also the angle, but mostly the sides is the really important part. That's going to tell you a lot of information. So if I have two triangles, okay, I have two congruent sides, you can see in a congruent angle. The angle is angle S and angle Y. You can see there's an arc mark there, okay? So what I'm going to do here is, okay, the thing I have to check for side angle side, does that arc mark at angle S and angle Y touch both the highlighted sides? Okay, in this case, yes, it does. You can see that arc mark, okay, it literally touches both of the highlighted sides there. Okay, so now take a look at this example. So the one on the right does fit the description. Okay, you can see that angle at angle S touches both the highlighted sides. Now, if you're looking at the triangle on the left, you can see that angle with the side that has no letter, you can see it only touches the side with the single tick mark. Okay, so in this case, the triangles are not equal to each other. All right, so let's go over two more examples of what that means. Okay, so does this one fit the criteria? I'm going to go ahead and highlight the sides. Okay, you can see for side angle side, the question you have to ask yourself is, does the congruent angle or the arc mark, you can see the little arc mark there, touch both of the congruent or the highlighted sides, right? The sides with the tick marks. Okay, in this case, the answer is no. Okay, you can see that angle that guy is pointing at, okay, only touches the side with the single tick mark. If we're going to use side angle side, it's got to be both. It can't just be one. All right, so take a look at this one. Does this one fit the criteria for side angle side? Again, the question you have to ask yourself is, does that highlighted side, in this case the double arc mark, does it touch both of the highlighted sides? In this case, yes. Okay, both of the highlighted sides, the angle touches both. So this does fit the criteria to prove they're equal using side angle side. All right, so that one's pretty good. All right, let's go into lesson 4-4. This one introduces angle side angle and angle angle side. All right, so I have two triangles. I want to prove they're equal. And what I have here is two angles, two congruent angles, and an equal side. So in this one, again, you're going to highlight all the sides and the angles. That's really going to tell you everything that you need to know. Okay, you can either do it in your mind, or if you're doing this on paper, of course, you can do it that way as well. So I have the two congruent sides. You can see in this example that highlighted side touches both of my arc marks. Okay, I have two congruent angles on the side. I highlight the congruent side, the side with the tick mark. You can see that highlighted side, again, touches a single arc mark and the double arc mark. That's what we're looking for, okay? So the question on the left is exactly the same as the left-hand side. And on the right-hand side, you can see when I highlight the congruent side, it only touches the single arc mark, okay? It's got to touch both. Now, we'll learn about another one that's like this, but for angle side angle, okay, specifically, all right, it has to touch both. And this one you can see here. When I highlight those congruent sides, you can see it only touches the double arc mark. We're talking about the triangles on the right-hand side here. The left-hand side is good, right? The highlighted side touches both of my angle marks. The one on the right only touches one. All right, now that's going to help us jump into angle side, okay? So you can look at the highlighted side to prove that these triangles are equal, okay? The highlighted side touches only the double arc mark side, okay? That's what we're looking for this one. If I had two triangles, I want to prove angle side, all right? It can only touch one. So let's take a look at one example of that. Okay, you can see, right? The triangle on the left. The congruent sides touch only the double arc marks, okay? And that's what we're looking for. Now, the triangle on the right, you can see it only touches one. Now, but here's the problem. This is just something you have to be like so slightly careful of, all right? You can see that the congruent side, I'm looking at the two triangles on the right-hand side here, they do not meet the criteria for angle side, okay? Those sides have to match with each other. You can see that the congruent side touches the double arc mark side, right? The side with the tick mark, and the tick mark on the triangle on the right only touches the single arc mark, okay? It's got to talk about the same side. We can't just have two random sides equal to each other, okay? They have to correspond. They have to match with each other. All right, so now let's go over like a super example of all of these. All right, we want to say, are each of these triangles congruent? And if they are, is it side angle side, side side, angle side angle, or angle side? So take a look at the one on the left. This one's going to be angle side angle. You can see when I highlight the congruent side, okay, the single tick mark side, and the angle marks, you can see that it touches both, right? When I have one that touches both, that's what I need for angle side angle. The one on the right is a little bit more straightforward, right? I see that these two triangles are equal to each other because of side, side, side. Each side corresponds with another one. There's a single tick mark side, there's a double tick mark side, and there's a triple tick mark side, okay? Each of those sides match with another one. You guys seem to be pretty good on that one. It's like one of the easier concepts. All right, so take a look at these two triangles. Are they equal? And if they are, how come? Well, I'm going to go ahead and I'm going to highlight those sides. Okay, this is one that you got to be careful with. So let's take a look at the triangles on the left. All right, I'm going to say they're equal, and they are through angle, angle, side. You can see, in this case, the base is the tick mark there. That base is equal to each other, and then I have two equal angles. Okay, you can see when I highlight the base, it only touches a single arc mark side, okay, not the double. And that's the important part, right? It's only got to touch one. The triangle on the right, okay, this is the key one here. So you can see that the triangle on the right, all right, when I highlight the congruent sides, this is what we're looking for, okay? You can see the triangle on the left fits the description for side angle side, right? That angle touches both the highlighted sides. Now the problem comes with that triangle on the right, okay? You can see that that angle, the one being pointed at and the one next to the X, okay, only touches the double tick mark side, okay? It doesn't touch the single tick mark side, that highlighted side. So this one, we're going to say cannot be determined or not enough information. Okay, it's either one of those. All right, so you got to be careful and look at both of the triangles. You can't just look at one. We're trying to prove they're equal to each other, so we got to look at both. All right, so here are some homework questions from chapter 4-4 that I need you guys to go over. So here's question 1. Okay, you're not going to have any proofs, all right? You're not going to have any ones like this on your test. But in this question, there's a lot of really important concepts, okay? So the first thing we need to understand is what angles and sides we're even talking about on this first line, right? What is angle BAC? Again, you have to be really, really good with these kinds of concepts. If you don't understand like what angles are being talked about, like when I say angle BAC, you're going to have a horrible time on the test. You have no, like pretty much no chance of passing. You guys have to practice with this if you don't understand. When I say angle BAC, you got to know I'm talking about that blue highlighted double, the double arc mark. I'm talking about that angle specifically. When I say angle ABC, you got to know I'm talking about that red angle. Okay? And when I say side BC, you got to know I'm talking about that green side. So what we're doing here is we're matching these angles in that side to the one on the right-hand side. So all I have to say is, okay, that angle DEC is the same as BAC. That angle ABC is the same as EDC. And that side CD is the same as BC. Okay, I've highlighted all of them because they're all color-coded to match each other. All right, you have to be able to identify angles and sides. You have to. Now, how do we know these two triangles are equal? Okay, take a look at the highlighted sides, all right? So we have one side and we have two congruent angles. So it's either going to be angle, angle, side or angle, side, angle. The question you have to ask yourself is, does that green highlighted side touch both the angle marks, like physically touch both of the angle marks? In this case, it only touches one. When it only touches one angle mark, okay, that's angle, angle, side. That's what we're looking for, all right? Is it angle, side, angle, or angle, angle, side, right? When I have two congruent angles and one congruent side, it's got to be one of the other ones, all right? In this case, it's angle, angle, side because the congruent or the green side only touches that one. The rest of these, okay, you can look over if you want. I'm going to go ahead and skip over them. It's not super, super important. Just that first part I really wanted to go over. All right, now, what we're going to do here in this question is we're going to take each of these triangles and we're going to go one by one, okay? We're going to see, does it fit the criteria for SSS, SAS, ASA, or angle, angle, side, all right? Now, let's take a look at the first one. Okay, I'm pointing at the first one. It's saying, right, we have two equal angles. Those are always given. Those are given information. So what we're going to do is we're going to take a look at these sides, and does these sides, do they fulfill the requirements of what we're looking for? So in this example, we have two equal angles and an equal side. So it's either angle, angle, side, or angle, side, angle. Okay, I've highlighted all the relevant angles and sides here. All right, so this one fits the description for angle, angle, side, right? You can see that that highlighted side only touches the double arc mark, okay? And that's the good thing. All right, that's what we're looking for. If it only touches one, it's angle, angle, side. Now, take a look at this one. If JK was equal to NO, I've highlighted all the sides and angles that you need. This one, you can see that the highlighted side touches both of my angle marks. If it touches both, right, the single arc mark and the double arc mark, it touches. This is what we're looking for angle, side, angle. All right, let's keep going. If KL is equal to MO or OM, okay, What would this one be? This is the same thing, right? It's angle, angle, side. You can see that the highlighted hypotenuse leg there, or I shouldn't say hypotenuse leg, you can see that the long side there touches only the single arc mark side, okay? It doesn't touch both. That's the important part. All right, now here's the last one. In this answer right here, it's saying if all three of those angles were equal to each other, would that prove that these triangles are congruent? Okay, the answer to that question is no. All right, now that's the really, really, really important part, okay? There's no such thing as angle, angle, angle. Does not exist, all right? So there's a question on your test that's directly related to that. It's going to ask you which one of these cannot be used to prove that triangles are congruent. You have to know that angle, angle, angle is not a thing, okay? It doesn't exist. All right, let's jump over to this question. This one's really, really, really important, okay? This is about that angle and side identification. You have to be able to name angles using 3 letters, and that's what this question is all about, okay? So what we're trying to say is these two triangles are congruent, so we're trying to find their matching angles and sides. So in this case, what's the same as angle ZYX, or ZXY, excuse me? And that angle is the one I'm pointing at. You have to know when I say angle ZXY, you have to know that that's the angle that's being pointed at here in this display. So what's the same? Oh, it's the same as XZY, or XZW, jeez, XZW. Okay, so you can trace your fingers on it if you want, if you're watching the video, okay? If you're watching on your computer, I should say. You have to know, okay, that really, I almost want to say the angle Z, but I can't because angle Z could also include that double arc mark side at the bottom. So I have to be more specific. I have to use 3 letters, X, Z, W. It's that middle letter. It's like you're carving out that angle. It's how I like to think about it, okay? So now what's the same as WXZ? You can see WXZ is that double arc mark side. So what I need is the double arc mark on the other triangle, okay? And that's YZX, okay? So think about it. It's the double arc mark side, so I need the double arc mark on the other side. And really, this is all about naming angles, okay? You got to be able to do that. Now, what's the same side as XZ on the other triangle? Well, that's XZ or ZX, okay? It's the same thing. And this is an important concept on your test. You're going to see this all the time. You're going to see that a side is equal to itself. We call that the reflexive property, all right? Now, the reflexive property is when we say a side is equal to itself. Okay, so these two triangles share the same side. It's not a different side on another triangle. They both share the same one. All right, you have to be comfortable with that concept, that we can say that these two sides are equal to themselves. Now, what's the same as WZ? This trips up a few people. Okay, it's XY. Why is that? Okay, as you can see that at WZ, when I highlight that side blue, you can see that it touches the single arc mark and the blank side. Okay, so I need to pick a side on the other triangle that fits that description. You can see that side XY touches the single arc mark and the blank side. Okay, that's the important part. That's what we're looking for. All right, question number 6. Let's keep going. This one again is an extremely important. Like I said, you're not going to have proofs. You're not going to have to do this double, the 2 table thing. You're not going to have to do a proof, but the concepts in this are just as important. So the first thing we always do in any proof, okay, the first line's always given information. That one's pretty easy. Now, how come I know that these 2 angles that I'm pointing at, RQS and TQP, how do I know those angles are equal to each other? How could I possibly know that, okay? Now, there's no arc marks there, but I know they're equal because they're vertical. Vertical angles are equal to each other, okay? You see how it creates a little bit of an hourglass type of shape, okay? And when it creates that kind of hourglass shape where those angles are straight across from each other, all right, that means they're equal because they're vertical, all right? Vertical angles are equal to each other, all right? Now that you know that they're equal, okay, I can create those little arc marks, all right? I'm going to create a double arc mark to show you. So taking a look at these triangles, how do I know they're equal to each other, right? I see I have 2 equal angles and an equal side. So I know it's either angle, angle, side or angle, side, angle. So the question you have to ask yourself is this. Does that highlighted side with the single tick mark, does it touch both of the angles or does it only touch one? Okay, you can see that it only touches one. You're going to see essentially this question on your test. You have to first identify vertical angles, and then you have to identify is it angle, angle, side, or angle, side, angle, or whatever the case may be. Sometimes it's side, angle, side. But you have to be able to understand, okay, what angle that vertical angles are equal to each other. Okay, you have to understand that. That's like the baseline piece of information. All right, now let's get into the last lesson here. The thing you need to understand is the HL theorem. So when we use the HL theorem, we need 3 things. All right, the first thing that we need, and maybe the most important thing, okay, this is like the first check that you're going to do if it's the HL theorem. Take a look. Is there a 90-degree angle? The 90-degree angle is that little box symbol that you see there. Okay, so in this case, yes. All right, we have to have a 90-degree angle. We have to be working with right triangles to use the HL theorem. We also need an equal hypotenuse leg. Okay, the hypotenuse leg is the diagonal line, it's the long line. Okay, whatever you want to, however you want to think about it. Okay, we need that as well. And we need either a base or a height. It can be either equal base or an equal height. Okay, we don't need both. We only need one. We either need an equal base or an equal height. Okay, in this case, it's the base. So keep that in mind as we finish out this lesson. Okay, so here are important homework questions from chapter 4-5. So take a look. All right, we want to prove that these two triangles are equal using angle side angle. So there's about like 4 or 5 questions exactly like this, essentially exactly like this. You're just gonna have different letters. Okay, so it tells us that first of all we have a right angle. You can see because of that box, angle A and angle E are right angles. That's what that box means. Now the question also tells us that AC is equal to EF. So again, we're trying to prove angle side angle. So now, whatever angle I choose, okay, it has to touch that highlighted side. It has to touch the highlighted AC side and it has to touch the highlighted EF side. Okay, remember, angle side angle. That highlighted side has to touch both of my angle marks. So what we're missing here is the angle. You have to be able to recognize that, okay? So if I were to highlight that angle, it would touch the highlighted side. Okay, can you see how angle C and angle F touch that highlighted side? All right, so you have to be able to identify what's it looking for. Is it angle side angle, angle side? In this case, it's angle side angle. So I'm looking for an angle that touches the highlighted side. All right, so that's a little bit different from this question. Okay, in this question, it tells us that angle B is equal to angle D. So now we're looking to complete angle side. It gives us both the angles, right? Angle A and angle E are right angles, so that's one angle. And then it also tells us, the question tells us that angle B is equal to angle D. All right, so what we're trying to prove is angle side. So what we need to know about angle side is that whatever side I choose, right, we're looking for a side, not an angle. When I look at it, okay, it has to touch only one of the angle marks. It cannot touch both, okay? It cannot touch both. So let's take a look. Can you see, right, when I highlight side AC and EF, in this case it's blue, it only touches the right angle mark, okay? So that's important. And then can you see when I highlight side CB and DF, can you see how that highlight side only touches the single arc mark side? Okay, that's what we're looking for angle side. It can only touch one of the angle marks, not both. Okay, so it can be either one of those choices. Both of those work. All right, now we have two right triangles and we're trying to prove, okay, each of these ones is going to fit into one of these categories. So essentially we're going to run through each of these scenarios and see which one it fits under. All right, so in this case, it says side QU is equal to RT, and it says that angle U is equal to angle R. So what I've done is I've highlighted the right angle, I've highlighted the equal sign, okay? So what you have to decide and what you have to look at is which one does this fit under, okay? So I've highlighted all the relevant angles and sides for you. So the question you have to ask yourself is, right, does that highlighted side touch both my angle marks, right? Because I have two angles and a side. So I know it's either going to be angle side or angle side angle. In this case, you can see that that highlighted side touches both of my angle marks. If it touches both, okay, that's what we're looking for angle side angle. All right, take a look at this one. This says that PU is equal to SR and that QU is equal to TR. Again, I've highlighted all the relevant angles and sides for you. So which one does this fall under? What category? Well, this one's going to fit under the HL theorem. Okay, some of you guys got tripped up and you think it's side angle side, but you got to look. Does that right angle mark touch both of the highlighted sides? In this case, no, it does not touch the hypotenuse leg. Okay, if it's going to be side angle side, it's got to touch both. All right, now it's the HL theorem because we have the 3 check marks, right? Is there a right angle? Yes, that's what that box is. Is there an equal hypotenuse leg? Yes, that's what PU and SR are. And the last thing we need is either an equal base or an equal height. In this case, we have an equal base, okay? Now, this one says that PQ is equal to ST, okay? And this says that QU is equal to TR. Okay, you can see, right? What does this one fall under? It's side angle side. I have 2 equal sides and an angle. You can see that that right angle mark, that angle touches both of my highlighted sides. Okay, that's the important part. Touches both. And then obviously the last one that you can see is that QU is equal to TR and that angle P is equal to angle S. All right. You can see that that highlighted side, QU, only touches the right angle mark. Okay, it doesn't touch the single arc mark. And that's what we need for angle side. All right, just a few more here. It's a little typo, sorry. Did not mean to add that extra slide in there. Okay, so we want to prove these two triangles are equal using the HL theorem. Well, let's take a look. It gives us the right angle. It gives us the equal base or height, in this case the height. And the last thing that we need is an equal hypotenuse leg. Okay, that hypotenuse leg is the long side. All right, AC and DE. If we have those two things, we have everything that we need for the AHL theorem. Again, you're going to have like 4 or 5 questions exactly like these last ones that I just went over. All right, now we want to prove these two triangles are equal using the side angle side theorem. So what's going to happen is, okay, I'm going to highlight the relevant sides. Okay, we can look at this from a couple of different perspectives. So the key thing here is when I have those highlighted sides, you can see the sides are highlighted. Now I'm missing the angle, right? I need the missing angle. Now remember, it's side angle side. That angle, if I choose it, if I draw an arc mark there, it has to touch both the highlighted sides. I can't just touch one. It's got to touch both. Okay, so what do we need? In this case, we need angle A. And you see how angle A and angle D both touch the highlighted sides? Okay, that's what we need. Now I can look at this from a different perspective. Just because it's a right angle mark doesn't mean I can't still use it as an angle, okay? So in this case, I'm going to highlight side A, B, and DE, and you can see the right angle mark, okay? Now, in this case, we're missing the side, right? I have the side, I have the angle, I need the other side. Now, if I were to highlight that side, okay, the key thing here is that I'm looking for a side, when I highlight it, that it would also touch that right angle mark, okay? Can you see how CB and FE fit that description, right? When I highlight that side blue, it also touches that right angle mark, all right? You got to be comfortable with that concept. All right, and the last question here, and then we're all done. So, what is the minimum information needed to prove that the triangular pair shown is congruent using the angle side angle theorem? So let's take a look. What I have here, all right, is a right angle, and I have an equal side, all right? So what we're looking for is the other angle, all right? So, angle side angle. If I were to highlight, we have the angle, we have the side, so we need the other angle. For angle side angle, that highlighted side has to touch both my angle marks. So I'm looking for an angle that would touch the highlighted side. So which one do I need? Okay, I need angle Q and angle N. You can see when I highlight that side, right, that both angles, excuse me, touch the highlighted side, right? And that's what we need. So, all right, that is the test review. Okay, remember, study guide, these slides, combine those together. You want to do both. Okay, you study those, you're going to be 100% ready for this test next week. All right. If you guys have any questions, you can email me. All right, and this video is obviously up on Canvas, so you guys can rewatch this if you want to. All right, so have a good day, guys. See you later.